Good morning, Miss Neville Science students. Here is our first recorded lesson, and we're going to be talking about severe weather systems. It's important for us to understand that severe weather happens just like if you look outside right now, you may see dark clouds, cumulonimbus clouds, and thunderstorms, but higher temperatures. Why does that occur? Well, we're going to talk about it today. Our learning objective today is to construct an explanation that illustrates how severe weather systems are created. So let's go ahead and get started. What I'm going to do through a lesson is I will underline or highlight the important parts or pictures that you need to draw in the lesson. Okay? So if Miss Neville doesn't highlight it, you don't need to write it down. So severe weather systems, what are they? When we talk about severe weather, what is Miss Neville referring to? It's important for us to know that severe weather that we need to know about as a 6th grade South Carolina meteorologist is thunderstorms, hurricanes, and tornadoes. Please take some time and always feel free to pause this video if Miss Neville goes too fast so that you can get the notes that you need to get. You are not required to draw these pictures yet. We're going to find that thunderstorms, tornadoes, and hurricanes all have something in common. And so let's start discussing what they have in common, beginning with their birth. So how are severe weather systems created? We're going to learn for the next 2 weeks a lot of factors. There are many factors that tell us how weather systems are created. Today, we're going to start to talk about one main factor, high and low pressure systems. You may hear a weatherman say there's a high pressure system in this part of South Carolina or a low pressure system in this part of South Carolina. To what is he referring? What is he talking about? Let's take some time, please, and draw these two pictures in our notes. Be careful of the colors that you use here. Notice Miss Neville used a blue for my H, which means high pressure system. Be sure you draw those directional arrows the same way Miss Neville has. Make sure you use a red crayon or colored pencil to represent a low pressure system, that red L, and draw your arrows correctly. That's extremely important. So let's review what air pressure is when air is pushing down on us. Remember, we should have learned with our old science teachers that, and you do not need to draw this picture, we should have learned with our old science teachers as altitude increases. Remember, altitude is our height from the sea. As altitude increases, the amount of air pressure decreases. Increases means to go up, decreases means to go down. Why? Well, let's look here at our model. High air pressure means more of those air particles are compacted together. They're very close together and constantly hitting each other. But the higher we go in the sky, the more those air particles spread apart and they spread out, and that makes that air less heavy. So the higher we go with our altitude, the lower our air pressure is. So let's start thinking about that when we talk about a high pressure system. In your notes, I would like for you to write high pressure system. We've already drawn this picture, so we don't need to draw it again. And we want to remember that cold sinks. Heat rises and cold sinks. What law is Miss Neville talking about? Did you think of the law of convection? Very good. Star statement, important fact that we don't want to forget in our notes. We want to remember that the law of convection states that heat will always rise and cold will always sink. And that's because of the weight of those particles. Heat, hot air, hot liquids rise to the top because they're lighter. This is the same reason why if you or I were to get on a seesaw, Miss Neville would go down first. It's because I'm heavier. So heat rises because it's lighter. Cold sinks because it's heavier. And so it causes a cycle or circulation of heat. That's why if you live in a house that has more than one level, that top layer of the house is always tougher to cool down in the summertime because heat rises. So when we're talking about cold air sinking, we have to think of a high pressure system. That's why we drew that H blue. So a high pressure system makes the cold air sink down. And when that cold air sinks to the ground, it pushes all the other air that was at the ground level, it pushes it out. It spreads it out. Take your hand on your desk, and I want you to pull your hand down like this. And when you go down, you spread your hand and turn it. Spread your hand and turn it. Spread your hand and turn it. That's what happens with air during a high pressure system. It causes those heavy air particles that are cold to sink to the ground and spin and push air molecules out. So that's how a high pressure system occurs. Remember, if Miss Neville goes too fast during a recorded lesson, rewind me. Please pause me so that you can get the notes that you need. A low pressure system is the exact opposite. What we need to understand about a low pressure system is that it causes warm air that's lighter. Remember, heat rises. So it causes that warm air to rise up. So when that warm, lighter air rises up, it creates a vacuum that sucks air and it spins. Can you do that with your hand? Warm air in a low pressure system sucks air up and takes it into the sky. That's why we drew that L red. So we want to make sure we know here that lighter, less heavy, warm air rises and creates a vacuum. A kid yesterday in class said, Miss Neville, you mean it's like a plunger? Yes. Just like a plunger sucks water up, that's what's happening in a low pressure system. Take some time to finish this up. Pause if you need to. So our next question that we'll need to write down today is what kind of weather is associated with a high pressure system? What kind of weather is associated with a high pressure system when that cold air is falling to the ground and pushing air particles out? Fair weather. When it's a high pressure system, the weather around us will be fair or good. That's a new word you're possibly learning today with me. Okay? In your notes, if you would draw your own sunny picture under this question and answer, you don't have to necessarily draw my very detailed picture. You can draw your own picture of fair, good weather, possibly with a beautiful sun in the corner, with nice, beautiful grass that's green, very healthy trees. We won't see rain here. We may have a little bit of wind, but this is the weather we want to go outside and play in. Fair, good weather. So, if high pressure systems bring fair weather or good weather, A low pressure system will bring what kind of weather? Did you say bad? You're correct. What kind of weather will a low pressure system bring? Severe, bad weather systems. Okay, so you're going to write this question and answer. And as always, you're going to draw your picture of a bad, maybe thunderstorm. You could draw a tornado, dark black cumulonimbus clouds, thunderheads. Draw your own picture as well of a severe weather system. So today in our live session, we're going to review what a high pressure system is. Then we're also going to start talking about identifying these high and low pressure systems on a weather map. I look forward to seeing you in class today for my first period at 12:28. Don't be late. And for my second period class at 1:06. Have an amazing day, guys. See you soon.